And in time for our next speaker, Josh Carlson, who's going to talk about some old school mapping using new school technology. Totally cool. I've heard this was the best talk at Foster G. That's what Elizabeth said, and she's going to stand behind that. So,
I didn't give this talk at Phosphor G. I talked about it to her, but
oh, okay.
I was talking to Martin about it before the workshops too.
Okay, I'm gonna hit play and see how this goes. Ready
All
for
right,
it?
ready.
Let's see. I want to share this other window here, and then go for it.
All right. So this is the story of one very specific map and the PostGIS function SquareGrid, which allowed me to accomplish what I needed in the way that I wanted. So a little backstory, Kendall County offers GIS services to some of our local municipalities who don't want to shell out for a contractor or can't afford to run their own GIS department. The City of Yorkville recently signed on with us, and one of the requests that came out of that was for us to recreate a map that their police department used. So this map hadn't been generated since 2022. There'd been some annexations and new developments since then, so it was in need of an update. We told them, go ahead, send along the most recent copy you've got, and we'll see about creating a newer version of it. The PDF was just a whopper of a file. It was 40 megabytes. It had things like the entire county parcels layer embedded in it as a vector layer, and just some things like that we'd have a chance to do things our way. But the important thing was to look at this map and identify the essential components. What does this map really need, and what is it for? As far as what it's for, this map is pretty basic. It's going to be printed out, so it doesn't have to be interactive. Nothing has to be performant. It's just printed out and tacked up on a wall. The police are going to be looking at this for a quick reference of where the streets are in the city. So the components are, we need the streets, we need the municipal boundary, and then we need some kind of alphanumeric grid, sort of battleship style, like A1, B2, and we need an index that shows for every street alphabetically what cells of that grid do they fall in. Beyond that, we just need some other features for context, maybe some surrounding municipalities, water features, major roads, things that will help people orient themselves based on nearby landmarks and other features. Whenever we start a new project, one of the questions we ask ourselves is, can we do this with OpenStreetMap data? If the features are missing, can we add them and then do it? At the county, we use OpenStreetMap for pretty much everything that we can. And all of our staff are trained in how to edit OSM. We are editing it daily. We like to think that we've got the county area pretty well mapped out. So anytime we can use that as our data source, we know it's going to be really high quality. It's going to be pretty up to date. So we look at those things that we need in our map. Well, we've got streets and the city boundary and some of those reference features nearby. Those are all, the bread and butter of OpenStreetMap. That's easy. But then we have this grid, and the grid, that's not really something that should be in OpenStreetMap at all. It's just this ephemeral thing specific to this map. So we can do most of this with OSM, but we've still got probably the most important layer, and that's got to come from someplace else. The second question that we ask ourselves when we're starting a new project is, can we avoid creating any new layers? Does the data already exist somewhere, in our catalog, and we can just reuse data from someplace? Or is there something that we can do to generate this on the fly using a QGIS expression, a geometry generator, or just spatial SQL? And, I'm looking at this. We're going to be making the map in QGIS. We're already writing SQL query layers to pull the OSM data out. And we're pretty familiar with spatial SQL. And, the feeling is there's just got to be a function for this. We don't know yet because it's not something that we've done, but but there has to be some way of dynamically generating it from the data that we've got. And, this is the first time that we're making this map, but odds are next year or next time there's a big annexation, they'll want an updated copy of this. So if all of our layers can be straight from OSM or dynamically based on an OpenStreetMap feature using spatial SQL, that's going to make future maps simpler. We just open, refresh the query, and reprint. So we feel like it's going to be possible. So now we're getting into the layers. The first one we want to tackle is that grid. And like any good GIS professional, the first thing I did was do a web search to see if, maybe there's a Stack Exchange, maybe there's a Python tutorial, maybe somebody's done this. I had a feeling that if I could pass the bounding box for the Yorkville feature from OSM, I could use that to kind of build rectangles. I don't know. So I was pleasantly surprised when the very first search result was PostGIS's own documentation. It was the SquareGrid function. Taking a look at those docs, I could see that, one of the examples they give in there is exactly what we're trying to do. You pass it a polygon, in this case, the city boundary, and you specify kind of the grid spacing, and it's going to spit out a bunch of squares. So the first thing we do is just recreate the example from the docs page. In this case, we just pull a number out of our hat. It's 1,000, sure. And we're going to cast everything into the state plane system that we're working with, just normally in our day-to-day work. Probably don't have to do that because Kendall is like a nice little square county that's pretty well aligned with North, but I figure why not? Let's just work with state plane. Anyway, so 1,000, it's way too small. Sure that would work, but the index would be insane. So then we're just fiddling around with numbers to see what this looks like. And 10,000, well, that's too big. Then everything's going to be in just a few cells. And 5,000 is about right, but the southwest corner is just barely in that other cell. So I don't know, let's take it down to 4,800 just to tighten things up a little bit. And I'm pretty satisfied with that. We want an index where the cells are small enough that it's meaningful when a road is in that. It's not just narrowing you down to 1/2 of town, but you also don't want so many cells that the index is going to be a poster of its own. So we've got our grid and everything's looking good, but how do we get the alphanumeric part? We want labels here. So I noticed that the grid squares, they're coming out with these I and J values. And I don't know, there's probably a perfectly good reason that they're starting at 193 and 372. Maybe that has something to do with the projection that I'm in and my distance from the origin. But we want them to be battleship style. So, we want row 383 to be 1. We want 382 to be 2. So there's a simple numeric relationship there. And then we want 193 to be A, 194 to be B on the columns. I don't want to hard code anything though. I could just write, 193 minus the value. But what if they make an annexation that kicks the city further out west, and now the lowest number is 192, and now I've got a negative number in there. So I don't want anything hard-coded if I can help it. I want everything to be dynamic and adjustable. So the first step there is to just pull the minimum I and maximum J values from the grid in a CTE, and then use those values together with each grid cell's own I and J values. On the letter side, we're taking the minimum I value away from whatever each cell is. So we're starting at 0, and then we're adding 65 to that and passing it into the character function, which means we're starting at A and going up the alphabet from there. For the letters, this is a little different because the highest Y value, or sorry, the highest J value is supposed to be 1, and it goes in the opposite direction with the numbers. So lower J values should be higher numbers on my grid. And so we're just taking the maximum away from the J value and then just flipping the sign. So that gives us our number. And the end result is exactly what we want. We have a grid covering the city of Yorkville, and it has an alphanumeric index that we can use to refer to any cell that covers this entire area. And just to demonstrate that it is dynamic and flexible like we want, I just passed that same expression, but for different municipalities. And we can see that Plano and Oswego both get a nice battleship-style grid, just like Yorkville does. So that was really nice and easy, much more so than I was expecting at the outset. The SquareGrid function really made quick work of the grid. But now we come to the streets. So our database, we pull OpenStreetMap data for the region every night and just dump it in there. We just have 3 tables, one for nodes, one for ways, one for areas, and we just throw all the tags into a single JSON B column because we don't always know what we're going to use it for. We just want all the tags available. So with that, we use the little double arrow accessor to pull values out. So we've got the name tag, and we're using it again with the highway tag to just make sure that it's traffic roads. We don't want steps and sidewalks and things like that. We just want the streets. But we don't want all the streets. The police department doesn't have any jurisdiction outside of the city. So we're only interested in streets that intersect with the city's boundary. Normally, that'd be a great time for a spatial intersection, but thanks to a former intern of ours, Adam, every street in Kendall County, well, almost every street in Kendall County has an operator tag on it based on who is in charge of that road. So rather than doing another costly geometry operation, we can just filter by the tag and look for streets where the operator is the city of Yorkville. And we'll just use some regular expressions because I'm pretty sure they all say City of Yorkville, but maybe some say just Yorkville or Yorkville Highway Department. I don't know, but we'll just use this, and this will give us every road where Yorkville is listed as the operator. Except it turns out there are some roads that they don't operate in the city boundaries. We're talking county and state and federal routes. So we need to make sure that we're including the county and IDOT as operators as well. So we include them, good. Everything looks great. Except if it is a numbered route, somebody might refer to it by that. They'll say Route 34 instead of Veterans Parkway. They'll say El Domain Road instead of County Highway 7. So we want to make sure that we can include the route information as well as the street information. And if you're familiar with those in OpenStreetMap, you know, the streets participate in this larger route relation. For us, when we're dumping OpenStreetMap data into the database, we just grab the route relations as big single merged lines with all of the relation tags on them. So they are available in the same table, but they don't have the same tagging. So we'll just mess with the filter there to include anything where the route is a road type. And then that's pulling them into, you can see them highlighted in red for reference. So we've got all the roads and also the routes. So the next step is where we're bringing everything together. We want to find out what cells do these roads fall in so that I can just look at, you know, El Domain Road and see a list of A1, B1, C1, things like that. So that's pretty easy. It's just an intersection between 2 layers. Thing is, the one layer is just a query-based thing. So it's going to get a little hairy here, and I'm not a spatial SQL wizard, so this may not be the best way to do it. It's certainly not performant, but it's just for a print map. So I'm not really concerned about performance here. But we take that entire query from earlier that we used for the grid, and we bring that in as a CTE, and then we intersect these streets with those. And it had been a while since I'd done this, and I forgot, if you've got a feature that intersects with multiple others, you're going to get multiple features in the output. So I've got, dozens of roads all over the place for every cell they intersect with. So it's time to aggregate things. The first thing we have to do actually, because even if we have the cells aggregated at the end, in OpenStreetMap, a road is split anytime its attributes change. So we actually may have multiple, West Spring Streets. So we need to aggregate our road geometry by the name, because that's really all we care about for the index is what's its name. So first we do a union, we group by the name. Then after that, we can intersect with the grid and re-aggregate the intersected features. And here we'll use the string aggregate function to take the letter and number from the grid intersections and just stick them together into a comma delimited string. So far, this is looking really close to what we want in the data table, but then I notice West Spring Street or East Spring Street, those are actually going to be sorted differently because of their prefix. But the way the police want to use it is with the name, not by the prefix. So I need to move things around because that's just how they're tagged in OSM. I can't really change that. So that's just a quick find and replace. Do, where the name is like West something, change it to something, comma, West. And just take the West off of the front end, things like that. And then I find there is one edge case where it's called West Street. So we have to hard code that in to just don't mess with that one. But the rest of them, any kind of cardinal direction, move that to the end of the name so that we can then sort them by the actual street name and have that be accurate. And then it turns out that not every route relation actually has a name tag. It's typically sufficient for a route to have a network and a ref. So, so for something where the network is USIL and the ref is 47, I want to stick those together and use that as a name for my routes. So we just amend our CTE to do that when the name or when it is a route relation feature. And so at the end of all that, we have a roads layer. And when we look in the attribute table, we find that every unique road name has its own row. And in that row, there's a column with just a single string of the cells of the grid that it intersects with. So this is what we want. Now we get to move on to some considerably simpler parts of the map, but still necessary and still PostGIS. So we want to highlight the city boundary. We also want to share the nearby municipalities just for that reference. So we do a simple query to bring in anything that is an admin level of 8 and also its name. And then we can change the symbology accordingly. We also take the Yorkville specific feature and symbolize that as an inverted polygon to kind of make a nice faded mask of anything outside the city. We also want some other roads in here. Actually, we want to display every road. We want to label city roads, and then we want to label major roads outside the city. So to do all that, we actually do a couple of different things. The first is those grid indexed roads that we worked up in that query earlier. We don't actually symbolize those. Those are just to drive the atlas index. The non-indexed roads that are just a simpler layer, we just add those. We include the operator and the highway tags so that we can get the proper symbology and labeling rules on there in QGIS. And that's it. Then we've got another query for waterways to get the names of the rivers and streams, and then water areas just because some of them are big enough to represent as polygons. So those are simple queries, but we pull them in, change the symbology, and that's it. That's our map. Honestly, the query was actually the easy part, or at least the interesting part. Once we had all of the layers in the map, now we actually have to make the layout and have it ready for printing. And that, I wish I had taken a time lapse of my desktop during this process because it was pretty tedious. But it was basically making text objects in QGIS, filtering it out to any features that start with an A, and then, making these little tables. And once I had them, then just nudging them by pixels until they looked really great on the layout. Of course, after spending far too much time nudging these little tables around, that's when Yorkville said, oh no, they can't be landscape, they have to be portraits. So then I had to readjust, change the number of columns, how wide everything is, what's the font size, just to make it look right with a portrait size map. But in the end, it was fine, and the query worked. So there's the map. And I think it looks good. We didn't need any of those extra layers that were in the PDF. We can export this, and it's a nice small file, and it does what it needs to do. And I'd like to go on the record and say that the Yorkville police were pretty pleased with our map. It did everything that they wanted it to do and had minimal visual distraction and clutter in the map. So it was great. But the reason that I put in all of this time and effort into not generating any intermediate layers on this go around is because within a month of exporting this, there were a couple of new annexations, and there have been a number of new neighborhoods that have begun development since then as well. So it's really only a matter of time before they come back and say, can you give us an update to this map? And when that happens, I'm just going to open up this QGIS project and it will be ready, except for, nudging those index tables all over the layout. But the data, the map, the symbology, everything's just going to work as the city changes and grows and the data changes. PostGIS and the SquareGrid query make it so that this index is just going to function properly no matter what. So I'd just like to take a moment to say, future me, you are welcome. And also just thank you to the Crunchy Data folks for putting this all together. And happy PostGIS Day, everybody.
Woohoo! That is a very cool and a lovely story, I gotta say.
Oh, thanks.
You really know how to spin a tale.
It was
So
a fun
have you
one.
been racking your head to figure out a way to make those tables without having to touch them?
You mean like the grid tables?
Yeah.
Yeah. I mean, I could just have a single QGIS table, and then maybe like do some wonky SQL to insert header rows, but they wanted kind of the A table to have a little spacing, and something above the B table to say here's the B's. If it was just one single table, A through Z, like that, I could just stick in the corner and forget about it. But I wanted to make it look nicer, so I imposed it on myself. But I have thought, like, there's still got to be a way to do this too, to make it a little less tedious. I mean, hopefully, they're only going to be adding like a few roads every time, so it won't change too much. It was the big change from landscape to portrait, where it's like, well, I have to redo all of this.
Oh man, this feels like something where web tech might become in handy. Like
Yeah.
HTML, the great layout, the great layout language. It'd be lovely to be able to just dump them all into HTML objects and let them bubble up to the right place based on a layout manager.
That's an idea.
Really intrigued by this idea of your county having all of its core data in OSM. Is
Oh yeah.
that for real? So you just maintain your in
That's
OSM?
as much as possible. Like our rule of thumb is if there's not a critical internal reason to keep it in a silo, it's going on OSM. I mean, as long as it's appropriate. We're not putting parcel boundaries on there, but and I've talked about this elsewhere. There's presentations somewhere out there, but we recently switched to where we're managing the county's address data in OSM because we've got a good QA QC process to make sure there's nothing getting deleted or messed with. But
Mhm.
if we just do it there, it's easier to work with, and it's already out there where the community can use it. So
Well, that's.
um,
Do you know any other counties doing that? I mean, I know one other
no,
jurisdiction doing it. That's it.
I know a lot of counties that get really nervous when I talk about it. They're
Yeah.
like, well, what happens? You can't secure it. But you know, I think when people see like the deep history of OSM, where you can look at the prior versions of anything, it's like, oh, okay, this is more secure than your enterprise geodatabase.
Yeah.
Just because it's replicated across I don't know how many servers across the world, and it's backed up for all versions, even deletes. Um, I feel a lot better about our addresses now that they're in OSM than I ever did when they were just sitting on a county box somewhere and nobody else could touch it.
Yeah. Do you ever get the opportunity to like show people, commercial apps that are like showing your latest data without you ever having to have told them about it? That's what I've always thought.
Um, I haven't run into that yet. Um, I mean, I guess, places that are using OSM data, like their address locators are more up to date than Google's, just because if they're using the Nominatum geocoder, that's every time we get a building permit with a new address, we just drop it in OSM and move on with our day. So
Yeah.
it's it's pretty nice. And we use other sites and stuff that take advantage of the OSM ecosystem. So we're dog fooding there, where we get to benefit from our own edits in
Yeah.
other ways.
Yeah. Is the rest of your team as fluent in SQL as you are?
Um, no, not in SQL, but we're getting there. We like to cross train and let everyone have a little taste of everything. We're a small department, so it's pretty easy to just say like, well, hey, what do you want to learn? Okay, I'll show you this. But they're all getting to know OSM pretty well, which is nice. I mean, we just hired a couple new people, and one of them's already editing boundary relations really well, which is like that's
Wow.
not a fun task in OSM, but they're doing it. So
Yeah. A question from the audience. Are you worried about digital vandalism or other users changing your authoritative addressing data?
I am not, because the community at large, they're pretty quick to recognize and address vandalism. And I did mention earlier, but we have some internal just validation steps that we go through. So it's just a QGIS project where we're looking at all the recent edits in and around Kendall, and we look at, okay, well, do we know this user? So there's some people where it's like, okay, they make great edits. We don't have to look at their stuff too close. Oh, this is a new person. They just joined OSM. Maybe we should just look at what they're doing and what they're changing. Um, so basically every edit that happens in Kendall County, somebody on staff is looking at that. And if they're not contributing to, or at least maintaining the level of quality, we try to address it promptly. So yeah, and we haven't had any vandalism touch like those core data sets. We just have people, plop a 20-story hotel in a farm field. That only happened once, but I've never had anyone, doing any mass deletions or modifications or it happened once, but it was reverted so quickly that it never made it into our validation database, because we're taking snapshots every 24 hours. So it's short answer is no, I'm not worried. But we have stuff in place just to verify. We don't just go, it'll be great, and we make sure.
Wonderful. Well, thank you so much for sharing your experience, your beautiful, beautiful map. I hope you don't have to nudge those boxes around too much more.
Yeah, it's going to be a reactive project. I'm going to wait for them to ask for it before I touch it again, but knowing it's there, then makes me feel a little better about it.
Great. Well, thank you so much, Josh.
Thank you.